Hello, gentlemen. This is the trigonometry, and today we'll be studying about the trigonometric functions. For the trigonometric functions, there are many types of functions like the sine, cosine, tan, cot, sec, and cosec. These are the functions for a particular angle, that is theta, where theta is this one. This angle being the right angle. This is obviously 90 minus theta. For the angles up to 90 degrees, we can calculate the values as the angle goes on increasing, and when the angle goes on increasing more and more above 90 degrees, there are special formula for calculating the values. So today we'll be reading about the formula for calculating the values when the angle goes beyond 90 degrees. The hypotenuse can be thought of being situated by two ways: with an angle of more than 90 degrees or with an angle of some value less the 180 degrees. So now let's try to know how to calculate the values in terms of the angle in excess of the 90 degrees. What if the hypotenuse turns beyond 90 degrees by the same angle theta? So now the hypotenuse will be at this angle because the angle made is theta here. So the total angle is 90 plus theta. Let's give the names. At 90 degrees, let's say it is A, and at the complementary angle, that is B, A1, B1. So for theta, cos theta will be B by H, that is OA, by H is OB. And for sin theta, P by H, that is BA by hypotenuse, that is OB. And what if the angle is more than 90 degrees from the original angle? And in that case, the hypotenuse will be in the position of OB1. So in that case, the triangle becomes OB1 and A1. The cos of 90 plus theta is the base. So the base is always at the x-axis. Now the base is equal to A1 B1 and the hypotenuse is OB1. Now we can see that the two triangles OAB is similar to triangle OA1 B1. So in that case, the ratio of A1 B1 by OB1 will be equal to, if compared to the original triangle, A1 B1 will be similar to the side of AB, but with a negative sign because A1 B1 lies in the second quadrant. So it is the negative of AB, and the hypotenuse is OB1, which is equal to the similar side, that is OB, and that is equal to negative of sin theta because minus AB by OB is equal to minus of sin theta. So cos of 90 plus theta is equal to minus sin theta. Let's say we calculate the value of sin of 90 plus theta. Now the perpendicular is OA1 and the hypotenuse is OB1. So by the rule of similar triangles, OA1 by OB1 will be equal to OA by OB if compared to the original triangle in the first quadrant. So OA by OB in the first quadrant represents the value of the cos theta. So sine of 90 plus theta is equal to cos theta. And similarly, we can find out value of tan theta, that is equal to P by B. P is OA1 and base is or B1 A1, which is equal to OA1 by B1 A1 is equal to OA by B1 A1, that is the negative of BA, which is equal to B by minus P, that is equal to minus of cot theta. And we can find out the value from this formula also. Tan of 90 plus theta is equal to sin of 90 plus theta by cos of 90 plus theta. Sin of 90 plus theta is cos theta, and cos of 90 plus theta is minus sin theta, which is equal to minus of cot theta. So it can be found out in two different ways.